Hello friends, today will be my fifth video in Cisco Packet Tracer, and today we will see uh, by the use of EIGRP routing protocols how we can communicate between different networks but belongs to the same under the same administrative control. Okay, so different networks belonging to the same administrative control, how with the help of EIGRP we can communicate between them. So first of all, EIGRP means Enhanced Interior Gateway Routing Protocol. So here by the term internal, it can also be understood that it is going to be only within the particular administrative control unit. So outside of that administrative control unit, it can't communicate. So here EIGRP uses the feature of both OSPF and the RIP routing protocol. In the OSPF we use link state protocol, and in RIP we use distance vector protocol. So in what ways EIGRP use both this protocol? So whenever this router wants to find its neighborhood, it will send hello packet, and this means it will advertise its network. So it is the same process. Uh, it is used in OSPF link state protocol. So whenever the router wants to form to discover its neighbor, it uses link state protocol, and whenever the this router form neighborhood, the neighbor routing database will be incorporated into the this the this particular router, or you can say the source router. So in this way this router can have the whole topology of the network. So whenever there is any changes in the topology, it will automatically update by the use of an algorithm which is all called as dual, which means diffusion update algorithm. And here are this some metrics are there. We also call it as k values, like bandwidth, delay, load, reliability, and the maximum transmission unit MTU. So here basically in EIGRP by default we use bandwidth and the delay, which is k1 and the k3. So the higher the bandwidth of the interface, the more chances for it to become the best route, or you can say the successor. And the delay, by delay means suppose if this router wants to communicate with this router, it has two ways, this by this router and by this router. This is the first way, and in another way from this to this, and here and here. So we have two ways. So suppose that both the this route have the same bandwidth, then which part will it choose to be is the successor, or you can say the best part? So the bandwidth are same, then it will check the delay. Say for example, uh, each interface has provide a delay of 10 seconds. Okay, here also 10 seconds, 10 10. So for the first route, from here to here 10 seconds, and again here to here 10 seconds. So overall it will, when here to here, your overall delay will be 20 seconds. And in the second route, from here to here 10, then another 10, 20, another 10, 30. So in the second route delay is 30 seconds. So the most desirable route will be the delay having the this less value. So the first route has the low value of delay, so it will, or if it will be the our best suited route successor, and the second route will be our backup successor, or we can call it as feasible successor. So in this way, it finds its suitable routes, and here, from here to here, how many hops are there? 1 2, and here 1 2 3. So all these things are to be checked in the this distance vector protocol, where the number of hops, everything will be counted, and the distance, how much distance between the this to this link cost, we also call it as. So lesser the distance, also it is the this higher distance, which is also called as the this feasible distance. Like from here to here, distance will be there, it will be the feasible distance, and here to here also feasible distance. And if you check the router 1 and router 2, feasible distance is lesser in the this router 1. So likewise, it incorporates both the attributes of the this link state protocol and the distance vector protocol. And here one term will become this autonomous system number, which is nothing but this networks belonging to the same administrative control are called as the autonomous system number. And for a particular this networks, for some networks belonging to the same administrative control, they will have they will share the same this autonomous system number. Okay, so in our current topology, I have taken this four networks, in which the first two networks are a subnetted networks of the classful address 192.168.1.0/24, which I have subnetted into two networks, 1.0/26 and 1.64/26, and which I have done for a particular specific region, which we will see as we proceed further. And this, in the third network, we have a classful address, classful network C address 192.168.3.0/24, and for network also similarly classful C address 192.168.4.0/24. Okay, and for easier purpose, I have already enabled the remote login privileges for each router. So first we have to define the serial interfaces IP. So let's first move to PC0. For the first network, PC0. Okay, then let's go to command prompt and the telnet 192.168.1.1. Username will be same as our last video. Admin the Cisco config t. Okay, and process our interface SE 0/1/0. Its IP address 192.168.1.129 and 255.255.255.252 and shutdown it the C0/1/1 next interface its IP address, then dot 0.0.1 255.255.255.252 and remote shutdown. Okay, and we have defined for the first router interfaces. Let's move to second PC number 1. PC number 1, then here PC number 1, let's go to telnet. This one telnet 192.168.1.65 and admin enable Cisco config t. Okay, here interface SE 0/1/0 IP address, then dot 0.0.2 255.255.255.252 no shutdown and jet next interface 0/1/1 IP address, then dot 0.0.6 55.255.255.252 and no shutdown. Okay, here this interface IP definition also finished. So let's move to this router number 3 having the interface SE010, SE011 and SE020. So PC number 2. Its gateway telnet 192.168.3.1 admin enable Cisco config t interface SE 0/1/0 this IP address 192.168.1.128. No, it should be 130 130 130 130 130, then the 255.255.255.252. Now shut down the interface SE 0/1/1 IP address this 10.0.0.5 255.255.255.252, and this now shut down, and the third interface TSC 0/2/0 IP address 192.168.1.141 255.255.255.252. Shut down. Okay. Yeah, it's finished. So here let me change here one thing. It should be like this. Okay. Now for this router, this interfaces IP definition is finished. So for the fourth router, let's move to PC number 3. For this interface is SE010. So PC number 3. Telnet 192.168.4.1 admin enable Cisco config the interface SE0/1/0 IP address 192.168.1.1.42 the this 255.255.255.252, and then now shut down. Okay. So IP definition is finished. It's 4.1 and 1.142. Here three serial interfaces will be there: 1.130, 10.0005, and this 192.168.141. Similarly, here 10. This 0.2 and the 0.6, and the 1.129, and the 10.0.0.1. Okay, fine. So our IP definition is finished. So before enabling this EIGRP routing protocol, let's just see how it looks like when we try to ping, let's say from this first network PC0 to the PC in this different networks. So let's move to PC0 first. Okay. For this, let's exit from this router mode and ping the first network 192.168.100.66. It says destination host unreachable, and similarly ping for this 3.2, which is also destination host unreachable. And the network 4.2, which is also destination host unreachable. So the router has no idea where this destination network has to be routed. uh, for that purpose, so we have to start this enabling the routing uh, in this EIGRP routing protocol. So let's start from this our first network PC0. So again telnet to the gateway 192.168.1.1 admin enable Cisco config D. Okay, here to enable the EIGRP routing protocol, we have to put one autonomous system number, just like in OSPF. We have defined this process ID and area number. So likewise in EIGRP we have to define one autonomous system number, and for networks under the same administrative control, the AS number or autonomous system number must be same. So let's say its autonomous system number AS number is 30. Okay, so as soon as I have this define the AS number, the router will enable the EIGRP protocol and set one router ID, just like we have seen in our OSPF. The highest, or you can say the greatest IP address assigned in its interfaces, the highest one will be the router ID. So similarly in EIGRP also the same, this funda will be there. The biggest or the largest IP address in its interface will become the router ID. So okay, just let's see. To see it's this one, it's router ID. So PRGRP topology. So here we can see the AS number is 30 and the router ID is 192.168.1.129. So let's confirm from our this topology what interface it has. It has the first interface is this, its gateway 192.168.1.1. Next is 10.0.0.1, and the third interface is 192.168.1.129. So 1.129 will be the biggest one, and it is also in the 192 series, and the 19129 is the biggest. So this IP address will be set as the router ID for this particular network. Okay, and the config D router. So just like in OSPF, here also we have to advertise our networks. Only after that it will comes to know its neighbors, so which is nothing but the attribute of the link state protocol. So first network is 192.168.1.0, added wildcard 0.0.0.63, and this next network 1.192.168.1 dot this 128, and 0.0.0.3, and the third network 10.0.0.0.0.0.3. Okay, here I have defined the this advertise its network, and PC0. So for PC, for the first network, this network advertisement is finished. So for the next network PC1, telnet 192.168.1.65 admin enable Cisco config D the EIGRP AS number must be same, so 30, and the network advertisement 192.168.1.66, and this 0.0.0.63, sorry, wait 1.64, 0.0.0.63, and this network second network is 10.0.0.0 and 0.0.0.3, and the third network is 10.0.0.4. So for this network this EIGRP routing protocol is defined and the network are advertised, and for the third network for the PC number 2. So telnet 192.168.3.1 admin enable Cisco config t. EIGRP AS number is 30 and network its first network is 192.168.3.0.0.0.255 because it is a classful this address having a subnet mask of 255.255.255.0. So wildcard marks would be 0.0.0.255. Network and this over this second interface will be 192.168.1.140. The 0.0.0.3, the third network interface should be this 1.128. The fourth network interface should be 10.0.0.4, 0.0.0.3. Okay. So whenever I want to add one more point. Whenever we advertise like this network 192.168.128.140, here wait, here I have done one mistake. This is wrong. EIGRP 30 1.128. This one is wrong, so network 192.168.1. This 128, right? 128 0.0.0.3. So whenever I define this advertise this network, what I actually advertise is the my interface which belongs to this network ID or network domain. So in this network my interface is 192.168.1.130. so 130 will be this advertising is that my this interface is 130. So the adjacent router or the neighboring router having the same network is network address domain 128. It will see and it will in its neighbor table, like yes, this 130 is the neighboring this router. So JIT, and this is for PC number 2. So for the third network also finished. So for the fourth network we have to move to PC number 3. PC number 3. So telnet .168.1 admin enable Cisco .50. So router EIGRP is number 30, and this network is 192.168.4.0.0.0.255 because it is a classful class C network. Then 4.1.140 wait, sorry, yes, 140 0.0.0.3. So let's just see here its neighboring details. So IP EIGRP neighbors. So its neighbor is only, it has only one neighbor having the IP of 192.168.1.141. so let's see here. So its neighboring router IP 141. Okay, and similarly for the third network, yeah, this is third network. So it has the three neighboring neighbor. One is 1.142, another is 10.0.0.6, and the third one is 192.168.1.129. so let's just confirm PC number 2. So exit P EIGRP neighbors. So 10.0.6 and the 192.168.1.129, and the third is the 1.142. Yeah, and here we can also see so IP EIGRP topology. And so here in class in this EIGRP, what happened, it by default this it advertise this classful network address or network domain. So even if we subnetted a particular this classful address, even though whenever this network advertisement is done, it will advertise as a classful network as a whole, but not as a subnetted version. So that's why here uh, let me bring to the screen for a second. Now I'm checking for this third network. So here just see my this net IP address is 10.0.0.5, and its network this this subnetted network is 10.0.0.4/30. But what this EIGRP is done, instead of subnetted version, it will directly broadcast this advertise the whole class full this class A address 10.0.0.0/8, and not the subnetted version. So again, let's move to PC number PC number 2. So here 10.0.0.8 is advertised. After that, it provide the this subnetted version is connected to its serial port, means this 10.0.30 this visible distance, this is the best suitable route to reach its adjacent this router having the address of 10.0.0.6, which is also a part of this subnetted version 10.0.0.0/30 by this the next our second network router interface 10.0.0.6, which is the neighborhood. So likewise, this router will come to know the whole topology of the network through its from its neighborhood this database. So in short, EIGRP maintains three type of table. One is the this neighborhood table, where we have see it store the neighborhood details. Okay, and the second one is the topology table, where through its neighborhood database it comes to know how it will connect to its final destination network, how it will choose the this path, perfect path. So all those topology will comes to know from the neighborhood this advertisement details. And finally the last one is the routing table. Okay, so likewise, um, for PC1, for this second network also, its neighborhood detail will be 10.0.0.5 and 10.0.0.1, and this network will be advertised as this 10.0.0.0/24 sorry /8 as a whole class A network domain. Okay, and uh, and also this thing, one thing here, why I have this subnetted the whole class C into two subnetted network. For this, to know why I have done, let's see into the PC1. For PC1, telnet 192.168.1.65 admin enable score config. These are neighbor detail. The topology. So in topology, this it has this class C. The classful address is this 192.168.1.0/24. So here the network, this it has the subnetted network of 192.168.1.64/26, but EIGRP it will advertise the classful network address 192.168.1.0/24. Even though this is a subnetted network, it will advertise as a whole classful network address. And similarly, when this router will advertise this the first subnetted network 192.168.1.0/26, it will advertise this as a classful address 192.168.1.0/24. Then it will be a ambiguity to exactly locate in which location. Suppose if we are this sending packets or packets from this PC to this PC, then whenever it will broadcast, try to communicate, it will broadcast the classful C address 192.168.1.0/24. So from this side also the classful C address will be advertised, and from this also the same classful C address 192.168.1.0/24 will be advertised. Then there will be an ambiguity in which direction it has to proceed. Because there is a drawback in the EIGRP. Whenever to this whenever there is a this contiguous this network exists separated by a different class network, then it will be an ambiguity to determine in which location it has to route it. So for that purpose I have subnetted that class C domain into two subnetted version, and for the first network also, let's see. PC1, so PC0, telnet 192.168.1.1 admin enable Cisco to IP EIGRP neighbors. So 10.0.0.2 and the 192.168.130 the neighbor, and the topology. So here also same. It has its subnetted network is 192.168.1.0/26, but EIGRP advertise the whole class C domain 168.1.0/24. Within it, the subnetted network 1.0/26 is connected to its gig port, right? So to understand further, let's try to ping from our first network to the remaining network 192.168.1.66. See, even though I have enabled this EIGRP routing protocol from my first network to second network, which is nothing but the subnetted network version of the class C domain, uh, because of that ambiguity, the router can't routed to the destination because it does not know in which direction it has to proceed. But for our third network, which is belong to a different this different network, this 192.168.3.0, which is another class C network. So for that, it won't be an ambiguity. So let's see for this it is okay, and similarly for 192.168.4.2, which is also another class C network, so it won't be a problem for sending packets. But for the subnetted network, which are separated by another network class, so from our first network to our third network, this is belong to 1.0/24. When it advertise, it will advertise as 192.168 1.0/24. When it comes to the third network, which is totally a different class, this different domain 192.168.3.0/24. So for this it won't be a problem, and similarly for 4.0, this also is not a problem. But when it comes to the same domain separated by a different class A here, class A 10.0.0/24 domain, then there will be an ambiguity, because from this side also it will advertise the whole class C 192.168.1.0/24. From here also same advertise, and so it will be a this ambiguity for the router to locate the this or exact this destination, how to route, and also even if even if we can't go from here, then it will find another route, like from 192.168 then here to here, this 1.192.168.1.128/1/1/30, which will also be advertised as 192.168.1.0/24. So from coming packet from coming from here to here is not a problem, it will come here, but when it will again diverted to this route, which is another again class A domain, then it will be again become a problematic, because this the same this subnetted networks are separated by another this class domain, class A. So for that, because of the auto summarization, this issue is happening. So to avoid this, what we have to do, we have to disable the auto summarization of the the auto summarization feature of the EIGRP. We have to disable. So first go to PC0, then telnet 192.168.1.1 admin enable Cisco and config t router EIGRP 30 and uh, here because the auto summarization this feature is already on, so we can also this check from here. Yes, so IP protocols, here it says by default on this automatic network summarization is in effect. See, so we don't want this automatic summarization for the first network and the second network. But for the this third network and the fourth network, it won't be a problem, because this both the this third and the fourth network belongs to this different network domains. So within a this same network domain, having a subnetted version separated by a different this class network address, in that case we say we have to disable the this auto summarization, uh, that feature. So for that, this for that we have to press PC0 here. So config t config t router EIGRP grp 30. So we have to disable, so no auto summary, so exit. Okay, and similarly we have disabled the auto summarization for the this first network, and for second network we have to do the same process. PC1 telnet 192.168.1.65 admin enable Cisco. Here also we can see so IP protocols. So here by default automatic network summarization is in effect. So to avoid it, config T router EIGRP is number 30 and the no auto summarization. Then we can check. Let's try to ping to the first network 92.168.1.2. Now it will start pinging because we have disabled the auto summarization. Now network 1 and network 2 will advertise its subnetted network only instead of the whole that classful address. Now it's pinging. So similarly for the PC1 also, let's see. For the PC1, no, sorry, for the PC0. Jet ping 192.168.1.1.66. Now it's pinging. So this is my second network, and my third network is already pinging because it is a separate network. Similarly the fourth network also. And after this we have, after disabling the auto summarization, now it will advertise only the this subnetted network. So for confirmation, let's see again. 192.168.1.1 admin enable Cisco. So EIGRP topology. Now here what does it say? It says 1.1.0/24, which is the classful address, is now routed by this route on the 10.0.0.2, which is the this its neighbor. Fine. So the router knows it will have to move through this interface. And before, what happened? Let's see again. And this is the before, when auto summarization was in effect. The same 192.168.1.0 was advertised, but no this perfect, what you call, in which direction or which this hop it has to move. The thing is mentioned. So because of that ambiguity, from network 1 network 2 there is no packet flowing. But yes, I have, after disabling the auto summarization, so if this direction has been provided, like whenever 1.0/24 has been advertised, then it has to, whenever I want to communicate on this part, then I have to move to the hop address 10.0.0.2 through this serial port. So in this way, this EIGRP works by the use or taking the advantage of both the link state protocol to this to discover its neighbors, and taking the neighbor database to form the whole topology. And whenever if there is any changes in the topology, then because of that dual algorithm, which is also called as which means diffusion update algorithm, it will update accordingly. And by the use of that distance vector protocol, it will check which will be the its best suited this route successor, having the what this visible distance, those things it will check for the network to have the fast convergence. So this is a simple demonstration how to uh, communicate networks belonging to the same administrative control using this EIGRP, this routing protocol. So thank you, friends.